In this problem here, we need to predict products. So we want to write the balanced equation with physical states, and also we need to identify what type of reaction this is going to be. Now, in this problem, notice we have a compound plus a compound. So two ionic compounds together. We have the iron 3 bromide and the sodium hydroxide. So what's going to happen here is that this is going to be a reaction for us. It's going to be a double replacement. In other words, the partners are going to switch. All right? So first thing we have to do, write iron 3 bromide. Writing the iron 3 bromide, iron has a +3, bromine has a -1, so we're going to get FeBr3. Now what would we expect this state to be? Well, if you're actually going to mix these together, this needs to be an aqueous state. And to that, we are going to add sodium hydroxide. Sodium, +1 charge, hydroxide, -1 charge. Once again, if you're going to mix them together, it has to be in an aqueous state. Now, let's see if these really are aqueous for what we do here. So, most chloride, bromide, and iodide salts are soluble, except those containing, what do we have here? Silver and lead and mercury. So, in fact, iron 3 bromide is aqueous here. And then hydroxides. Most hydroxides are insoluble, except for those of alkali metals and a few alkaline earth metals. Well, sodium's an alkali metal, so that will in fact be aqueous as well. Now to determine if this reaction actually occurs, what we have to do is figure out, is iron hydroxide, so we switch once again the cations. So if we switch a cation, is iron hydroxide going to be a solid? And in fact, most hydroxides are insoluble except those of alkalis. Well, iron's not an alkali. So it will in fact be a solid when we put these together. So what we'll do is we will take iron 3 hydroxide. When these react, will in fact end up being the solid. It'll precipitate out of the reaction. Plus, and then we'll have sodium bromide left, NaBr. And looking at the state of NaBr, most salts containing alkali cations are in fact soluble. So that will continue to be aqueous. So I'm going to rewrite this down below so we can balance this a little easier. Let's go with our iron 3 bromide, aqueous, plus my sodium hydroxides. I leave a little room so I can put in my coefficients, aqueous. And that yields iron 3 hydroxide, which is in fact a solid, plus my sodium bromide, which is and remains aqueous. So now what we want to do, we want to find out how we balance this. So on both sides we have iron, we have bromine, sodium, and hydroxides. So let's tally them up. 1 iron over here, 3 bromines. On the reactant side, we have 1 sodium and 1 hydroxide. On the product side, write down your elements once again just to make sure you're keeping track of everything. And for the irons we have 1, hydroxides we have 3, sodiums we have 1, and the bromine we have 1. Now obviously not balanced. That's our skeleton equation. So let's go ahead and balance these. I need 3 bromines on the product side. That gives me 1, 2, 3 total bromines. That also gives me 3 sodiums. All right? Now, on the reactant side, I'm going to need the 3 sodiums. That gives me 3 of those. and hydroxide, it ends up giving me 3 hydroxides as well. Now if we look, hey, our skeleton equation is now balanced. We predicted that this would give us, using a double replacement reaction, the skeleton equation, balanced it, we are done.